right, so grab a piece of paper and a pen or your notebook or whatever you're using to take notes, and here we go. 1.6, function operations and compositions. So we're going to use operations to add, subtract, multiply, and divide functions. And we are also going to use compositions of functions to combine functions and stuff like that. So that's where we're headed. Let's go there. There's the paper. 1.6. Function, operations, and compositions. Okay. Actually, we're going to pause real quick before we do that. The worksheet 1.5, we didn't go over that. I do have the key here, though. So the 1.5 worksheet was the homework from Friday. No, we're going about the pace that we would go in regular school, maybe a little bit slower even. Just because we do have longer periods now and stuff like that. And I guess it's faster in a sense because we're not taking as many days to test and quiz. Because usually we would do a quiz and then a quiz and then a big chapter test. But since we don't have time to, I guess, we are going to finish everything because what we're cutting out is extra test days. So we used to take more time to do quiz, test, and all of that stuff. But now we're just doing quizzes instead of big chapter tests as well. But yeah, so we should still make it through everything since we also have longer class periods to do it. But yeah, good question. Let's see. So the 1.5 practice, we had parent functions and transformations of parent functions. So the first problem, we should have moved this one left 3 and up 1. So the pink function is where it ends up. The green function was the starting one. On this one, we started off with the absolute value function, and then we reflected it over the x-axis, and then it was horizontal compression by a factor of 2. If you said it was vertical stretch, that's also close, but then the 2 would be on the outside. So if you're just looking at the function itself, like the notation here, we would say horizontal compression. And then let's see, the graph of f of x squared equals x squared, and then g of x, how they're related, reflected over the x-axis, and then it's translated right 1 and up 1. And then it would be g of x equals negative, parentheses, x minus 1 squared, plus 1 on the outside. Number 4, it was vertically stretched by a factor of 2, and then it was moved left 2 and down 3. So this pink function would be the new one. The green function is the original. And then down here, we've got a step function. I saw a couple of people do different things here with this, not realizing that this kind of double bracket here is the step function. And if you were typing it into Desmos or something like that, it would look like floor of x. So just something to be aware of there. I saw people mistake it for absolute value and also for just a linear function. So careful with those. The original one is the pink here, f of x, g of x is the green. So the steps are farther apart since it's been stretched. And then it's also been moved right 2. Then this one here, the original cubic f of x is the pink. And then the green has been moved to the right 2 and down 1 and also vertically compressed. So it should now look like this about. Anyway, those are the answers to the worksheet. So if there's a particular one that you missed, maybe go back to it and try and figure out what went wrong there or ask questions later if you have them. But yeah, okay. So back to 1.6. Function, operations, and compositions. Okay, so first of all, operations are most easily shown, and compositions too, actually, are most easily shown with an example. So we're going to start with operations only. So we're going to add, subtract, multiply, and divide functions. And we'll look at the notation that involves. So we're going to start with f of x equals x squared, and g of x equals x plus 1. So those are going to be our two functions. And the first thing we're going to do is addition. F plus g of x. Okay. So for f plus g of x, we are just adding the two functions together. This is the same thing as going f of x plus g of x. So f of x was x squared. G of x was x plus 1. So we get x squared plus x plus 1. All right, so there's adding functions. Then we're going to subtract functions. So we're going to go f minus g of x. And you could do g minus f if you would like to. You can add or subtract them, but we'll do f minus g for now. So f minus g of x is just f of x minus g of x. Now, the important thing here is to make sure that when you're subtracting f and g of x, that you put parentheses around the one that you're subtracting, especially if it has more than one term. Otherwise, you might end up with not actually subtracting part of it. So f of x was x squared minus parentheses g of x was x plus 1. Then you want to distribute the negative to get x squared minus x minus 1. Okay, so there's addition and subtraction. Then we're going to do division and multiplication. We'll do division first, just for fun. So it would be written as f divided by g of x. And this is where you just take f of x and divide it by g of x. You put them in ratio. So for this one, we end up with just x squared over x plus 1. And that's our answer for what f over g of x is. Okay. And then lastly, we have multiplication of functions. So that would be f times g of x, or you might just see it written as fg of x. Either way, those are two possible notations for it. I tend to not use this as often because it looks too similar to compositions, which is what we're going to do next. So I tend to just stick the letters next to each other instead. That way we don't get confused with the composition of a function. But anyway, it is just multiplying the two functions. So f of x times g of x, which is x squared times x plus 1. And then we would just simplify it. So distribute the x squared to get x cubed plus x squared. We could also be asked then, once we've got, our f times g of x, to plug in a value for x and figure out what that would end up giving us. So we might see something like fg of 3. So I would just take this new f times g of x and plug in 3 for x. So we'd get 3 to the third plus 3 squared. So we're just taking that function and plugging in 3. which would be 27 plus 9, which would be 36. Okay. So any questions with function operations at the moment? Any numbers we're not sure where they came from or anything like that? Okay. So function operations tend to be fairly straightforward and not what people struggle with as much as compositions of functions. So we're going to spend the bulk of our time today on compositions of functions. Okay. And we're going to use the same f of x and g of x as we did up here to show how we would do these. So f of x is still going to be x squared. G of x is still going to be x plus 1, just for the sake of keeping things simple here. Okay. So there's this notation when it comes to compositions where we have f and then an open multiplication dot g of x. And it looks like fog. And the way that we would say this with words is f of g of x. And what it would look like algebraically is like this. F of g of x. So basically what this is telling, like if you had f of 3, right? That would tell you to plug in 3 to your function f of x. What this is telling us is plug in g of x to your function f of x. So this would tell us, plug in 3 for x. This is telling us to plug in g of x, that entire function, anywhere there's an x. So in this case, that's like telling us f of x plus 1, since g of x is x plus 1. So anywhere there's an x, I'm going to plug in x plus 1 into my f function. So since f of x is x squared, this would just be x plus 1 squared. And then I would simplify this, so we go x plus 1 times x plus 1, since that's what x plus 1 squared is. And we would distribute, so we get x squared plus x, and then distribute the 1 to get x plus 1. So we get x squared plus 2x plus 1 for our answer here. Okay. So that's f of g of x. That's our new function, f of g of x. X squared plus 2x plus 1. So then, kind of like we saw up above with f times g of x and f times g of 3, we could also be asked to do something similar here. We could be asked, what is f of g of 5? So then I would just take 5 and plug it in for x into that equation. So 5 squared plus 2 times 5 plus 1, which is 25 plus 10 plus 1, so 36. So it's the same idea as we did up here, just plugging in a number then instead. All right. So we have f of g of x, but then we also have the other way around. We could do g of f of x. Which is the same idea. It's g of f of x. So that means that we're plugging in f of x to the g of x function. And I know that g of x is x plus 1. So I'm taking x squared and plugging it in to x plus 1. It's the same as g of x squared, which would be just x squared plus 1 then. So then we could be asked for a similar thing here, g of f of 5. And that would just mean that I plug in 5 to this x squared plus 1. So we get 5 squared plus 1, which is 26. Okay. So that's the basics of compositions. So let's try a couple more and kind of get used to this. But first, are there any questions on either of these? Numbers we're not sure where they came from, steps we're not sure why they happened. Okay. Well, then let's get some practice with operations and compositions real quick here. So I'm going to give us a couple of functions, and you guys are going to try adding, subtracting, multiplying, and dividing real quick. So we'll have f of x is x squared minus 1, and g of x is 2 over x. And we want to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So find those 4 things. And when you are finished, type done in the chat. All right, looks like most of us are finishing up. Maybe some of us are stuck. So let's go over some of these here and kind of what we're expecting as well, because on some of these, they might not look like they are simplified all the way, or it might look like there's got to be something more here, but there's not. So for example, for f plus g of x, we have x squared minus 1 plus 2 over x, and that is as simple as that one gets. And then we have f minus g of x, same idea. X squared minus 1 minus 2 over x. F times g of x does get a little bit more into something that we could simplify. So we get x squared minus 1 times 2 over x, which gives us, if we distribute here, 2x squared over x minus 2 over x. And so here you can cancel one of the x's in the top with the x in the bottom. So you can cancel that to get 2x minus 2 over x for the final answer on that one. So that's like the most simplified version of it. And then f over g of x can also be simplified, because we'll end up with x squared minus 1 on the top, and then a fraction 2 over x on the bottom. And since we don't want to leave a fraction in the denominator of another fraction, because that looks messy, what we're going to do is when you divide by a fraction, you flip and multiply, right? So x squared minus 1 over 1 times x over 2. So we just flipped this fraction and multiplied. So now we have this x times x squared minus 1 over 2, because you just multiply across. And we get x cubed minus x over 2 for our answer. Okay. So there's all of our new functions. We could also be asked about the domains of these new functions. If you were asked about the domain, it's good practice, anyways, to look at what the domain might be here. And for each of these, you can pretty much tell the domain just by looking at the function itself. Because all we're thinking about when we're looking for the domain is what values could x not be. So all of these first three have something in common. Is there a particular value that I could not plug in for x in those first three? Anyone think they know? Yeah. Katarina's got it right. It is 0. You could not plug in 0 for x to any of these first three, because you would have a 0 in the denominator issue. So 0 is a value that we're excluding from the domain of these functions. So our domain for these first three would be negative infinity to 0, union with 0 to infinity. Okay. So those are our domains there. And then the domain for this one is negative to positive infinity, because there is no x value that I need to exclude here. There's nothing in the denominator that would make it so that I need to exclude 0 or anything like that. Okay. So there's our operations with functions. Now we're going to get a little bit of practice with composition of functions. So if you don't have, or your composition of notes, words are hard. If your composition of functions notes are nearby, you're going to want to have those out just to make sure that you're on the right track with these first couple. So here we go. We're going to have two functions. So this is our next example. f of x is going to be 2x plus 1. G of x is going to be x squared minus 2x minus 4. Okay. So we are going to find a couple of things. We're going to find f of g of x, g of f of x, and f of g of 4. Okay. So take a moment on your own and try figuring these ones out, remembering that this is just like f of g of x, and this is like g of f of x. So here you're plugging in g, here you're plugging in f. Okay. So take a couple minutes and work on that. When you think you've got it, type done in the chat. All right, both of the Jasmines are done. And we got Carson. And Sean, nice. All right, looks like a good portion of us are done. So wherever you're at, if you're not quite done or if you're stuck, maybe take a look up here. So what we've got for this one, at first we've got f of the g of x function, which was x squared minus 2x minus 4. So anywhere there's an x in the f of x function, we plug in this whole thing. So we get 2 times x squared minus 2x minus 4, then plus 1 on the outside. So that's in place of x there. That's like our 2x plus 1. So then we distribute to all of these, and we get 2x squared minus 4x minus 8, and then plus 1. So overall, 2x squared minus 4x minus 7 would be f of g of x. All right. So that's our first one. Then g of f of x is a little bit more work because you do have to square something with more than one term in it. But here we go. 2x plus 1 squared. The part that people mess up on the most here is just distributing the square to both of these instead of actually multiplying the whole thing out and double distributing. So you do need to make sure that you have this as 2x plus 1 times 2x plus 1. So we end up with 4x squared, and then 4x plus 1. And then we distribute here as well. So we get minus 4x minus 2. And then we have that minus 4 still. And then when we simplify here, the plus 4x and the minus 4x cancel. And these like terms here combine to be negative 5. So we end up with 4x squared minus 5. Okay, and then our last one, plugging in 4 to that f of g of x function. So 2 times 4 squared minus 4 times 4 minus 7. So that's 32 minus 16 minus 7, which is 9. All right. So let's see. Here we go. That's all of our in-class example practice right now. We're going to jump to working on the assignment, and then if you have questions after that or want to talk about any particular problems, we can do that as well. Let everyone who thinks they've got it get going on the assignment. Okay, so today's assignment is 2 IXL sections. There's one on adding, subtracting, multiplying, dividing functions, so all those operations, and then there's one on compositions of functions. So it should look just like what we did in class today. With these, you'll add the 2 functions, f plus g of x, and you'll write your answer as a function in simplest form. So this one, negative 5x plus 5x plus 1, would just simplify out to 1. All right, so that's those ones. And then the compositions of functions we'll do here as well. So it would be f of g of x here. So I would take 2x and plug it in for x. 3 times 2x is 6x. Okay, so that's the assignment for today. I will have an exit ticket towards the end of class that I'll post. And then other than that, unless you have questions or concerns or anything like that, you are free to head on out of here and enjoy your Monday. If you have questions, I will still be around on this Google Meet until the end of class. Yes, this was recorded.